Hey everybody, it's Craig from Field-Based STEM, and I'm here with Taylor Thomson, who's another one of our scientists from Field-Based STEM. Hey Taylor.
Kia ora, Craig. How's it going?
Kia ora, it's really good. Great to see you. And I'm always excited to have the opportunity to speak with someone else from our Field-Based STEM team because I get to learn more about what you do. So why don't you introduce yourself and tell us about your background?
Yeah, sure. So, as you said to everyone, I'm Taylor. I've recently joined working for the team at Field-Based STEM. I completed an undergraduate in environmental science and psychology through Waikato University, and I'm just about to finish my master's in environmental science through Waikato as well. And that's building a ecological model for estuaries to identify ecosystem tipping points. So, there's some pretty exciting work going on there.
Tell us about tipping points and what that means in science, and particularly your area.
Yeah, sure. So a tipping point, an example of an estuary, you have two stable ecological states in many estuaries around New Zealand. The stable being a sandy shore bottom, clear water, sort of low in nutrients. And an unstable state, the other stable state that it can move into is that more of a muddy bottom, turbid environment, high nutrient. And how we switch into that state, it's a very gradual process. So if you think of a ball being pushed up a hill, rolling and rolling and rolling, and then eventually it's going to get to that point where that ball goes down the other side. So it takes a lot of work to push that ball up to the top. And once it gets to the top, flies down to the bottom. And that's the other stable state, which is that muddy environment that we don't want. And to get it back, it takes all that work and more to push it back up and get back into the right state. So what I'm trying to do is make a model using a few keystone species in the environment, and we're influencing them with nutrients and sediments to identify sort of in how many years we expect that proverbial ball to go over the hill. So hopefully councils and governing bodies can use that for their management of estuaries and become a bit more proactive rather than reactive.
Yeah, that's really great. And I just need to understand because I grew up in Whangaparoa and estuaries, they're all over the place and inlets, and it was just a magic place to play as a teenager and discovering things. And why would we not want to have that muddy bottom versus the sandy bottom?
So the muddy bottom, a lot of those key species can't dwell in there, and they're the ones that are going to be cycling those
Mm.
nutrients out. So the one I'm looking at specifically, Macamona liliana or wedge shell, it pumps nutrients from the pore through pore water from the sediment up back to the surface. So it siphons water from the top, eats its bugs, and then that pulls the water down while it's siphoning, pumps the nutrients back out. They can't dwell in environments that are too high in nutrients. So what's going to happen is you're going to get those sediments become very clogged with nutrients, and that system is going to interrupt itself in a way. You don't have the macamona eating the microphytobenthos or the chlorophyll. You're going to start getting those chlorophyll blooms, and then I feel like most people are probably familiar with what happens when you get those algal blooms.
Mm.
Yeah, it's not good for the environment. So really that muddy bottom, it disrupts a lot of species and where they can live, and obviously can hold a lot more nutrients as well, which is not good.
Yeah, so I think this is pretty exciting that as part of field-based STEM, we get to go in schools and work directly with teachers and share with them the research, the training, the background, the practical things that we're actually doing in our sectors and in our different industries. So why don't you share some of the recent experiences you've had working with teachers and students in schools?
Yeah, sure. So I spent last week up in the Auckland area. I'm actually living in Christchurch, so travelled up to Auckland, spent 5 days at 4 different schools. Went through Samhain College, Rosehill College, Pakari School, and Tapora School. So big range of students there. They aged from 5 right through till we had year 12s and 13s and some of the college classes there. And teaching anywhere from 10 students at a time to I think it was 65 in our largest day. So what I was trying to do in there was with the older students, it was a bit more structured. I attended field trips with the schools, and they had a bit of a process that they were going through, and I was there to help them with that. And For the most part, it was water quality analysis and streams around the schools. Selwyn College wanted to identify and create a monitoring program in the reserve behind their school. So that was a lot of exploration and finding out where the best spots to do the monitoring and teaching the kids and students how to go about it. Rosehill, was those field trips out and about, and they had things that they want to do, looking for macroinvertebrates, identifying stream health and environment analysis, looking at the stream banks and everything too. So there's a really big scope there. And with the younger students, it was teaching them about water quality and what makes those water bodies healthy, and then sort of creating an action plan for those kids to keep those environments clean after I've left.
I think that's an amazing thing that we get to do, where teachers and us as field-based STEM educators can do that professional learning with the teachers in the real environment out there in the field, and students get to participate in that while the teachers are with us and shadowing. We get to mentor, get to share the experiences and real practical cutting edge procedures that we do in our different sectors. I think that's exciting because I always learn when I get the opportunity to be with an expert. What do you think the value of the field-based approaches do you think for educators?
I think obviously field-based STEM opens so many doors to kids and teachers just to experience all these things that they never would otherwise. I feel like specifically in my field, I was never exposed to this sort of thing until I was, a few years into university, using the tools and the equipment. It's even second year uni, I think it was when we really started. And then my time working as an environmental monitoring officer with the Waikato Regional Council. We're out 4 days a week doing that sampling, covering a massive range of what we're doing, but you speak to the public and they don't really know what you're up to, and they don't quite understand.
No idea.
So, no, even when you explain it to them, a lot of them thought we were testing for COVID in the waterways. And so it's really nice to be able to take that to the students and get them to learn from a really young age and get them thinking about how they can preserve these environments for themselves so that it never gets to a stage where people have to come out and do restoration projects. And I think that spans a very wide scope for a lot of our field-based STEM people. It really gets the kids thinking about how they can preserve these environments so people like us and people like them in the future don't have to do all this work to bring it back to these pristine environments that we love to see here in New Zealand.
Just focusing on the educators and the teachers that we get to work with doing this professional learning and development, what are some key ideas and concepts? If there was just, you had 5 minutes to talk with the science teacher about things that they could implement in their program that are going to be really valuable, given the climate change impact on environment, pollution, things that are happening. What are those specific knowledge, understanding, or new developments that you would say, hey, be aware of this and implement these things?
Yeah, sure. I think a really big one is, I touched on a little bit of it earlier, that sort of environmental analysis. So you go to these water bodies and you identify the planting in the area. You do those water tests to see the quality. You have a look at what's around the area, how close they are to roads. And that really gives you an idea of what might be polluting these waterways. And a lot of the regional councils now are providing a lot of funding, especially for farmers to go out and do riparian planting. And for those people that might not know, there's the plants that live alongside the water bodies, so like your reeds and not necessarily flowering plants, but what they do is they soak up those nutrients before they get into the waterways.
Right.
With the Waikato Regional Council specifically, they were giving quite a bit of funding out for, like I said, farmers and anyone really that could get their hands on it to do that planting. And I think what's really a really cool opportunity is for schools to get on board with that as well. Obviously, a lot of people, especially farmers on big sections that may have these streams running through and want to do something about it, but don't have the time or the manpower. bringing those students in the schools and creating a project around that for the kids, and also getting to be a part of changing the environment and making it better, as well as just having it on pen and paper. I think that's a really big resource that schools should be looking into. Yeah, I think that would probably be my biggest one. Yeah, get the kids onto that.
Yeah, that's great. Awesome. Hey, Taylor, just as we wrap up, why don't you share with us your degree that you did and some of those key learnings that you've taken away from your degree, just for the teachers who might be counseling students about their career options in terms of the right kind of degree. If they want to do what you do, what sort of degree and what sort of key learnings in that degree would they counsel the students to look for and help them find that kind of degree if they're really interested?
Yeah, sure. So, with my undergraduate degree, doing the psychology and environmental science, I really wanted to learn how people tick and use that to my advantage in benefiting the
Mm,
environment. So, how can we implement changes in the environment in a way that people are going to support? Because there's no use in all these scientists throwing out all these ideas and implementing something that the public doesn't understand or doesn't want to understand, or um, doesn't want to be a part of, because there's so much jargon and specifics in science that if you're not a scientist, it's not really interesting at all. Um, and I'm finding a lot of the universities are kind of cottoning on to the same idea, and they are starting to branch a lot more of that social side into their science degrees. Only I'll harp on again about University of Waikato, but that's only because I'm familiar with it. They've just started a climate change degree, and that does branch that social side as well as that earth science and environmental side. So almost if you think of anthropology or geography, like the people side of things, and that puts those two together and really looks at how we can be making these changes that people are going to be on board with. So what I guess I would encourage teachers to do is not only get kids to focus on the science side of things, but join those enviro groups at school, get out
mm,
there and be a part of groups that are doing things, because you're going to understand the way that, unfortunately, understand the way that it works, and the way that things work in terms of restoration never ends up being the easiest way, because you need that public support to get the funding and to make those changes. And yeah, I'd encourage people to get out there and be a part of the community doing those things, so that they've got
mm.
the know-how or maybe even the influence to start making those changes.
Well, Taylor, thank you very much for the work that you're doing with field-based STEM and creating change makers with the teachers and the students that you get to spend time with, and sharing your knowledge as well. And I just saw some feedback as well from the high schools that you're with over the last couple of weeks, just absolutely loving their time and the development that they got to experience by being with you. So thanks very much for the work you're doing.
Thanks for having me.
Fantastic. So everybody else who may be watching the recording or watching live, you can see the website for field-based STEM scrolling along the bottom of the screen. So field-based STEM.kiwi. So that's also in the show notes with the video on YouTube and on Facebook and wherever you may find the video. We look forward to engaging with you for teacher professional development. And do remember, if you reach out to us on the website, to submit an application with you for PLD, for Schools and Ministry of Education does fund it. And we get the amazing opportunity to have experts like Taylor come into your school and share the latest innovations and where the industry is going. So we'll see you again on another Field-Based STEM videocast.